I bought this Motorola power amplifier, I mean that's what it says it is, a number of years ago, and I know it's suspected 403 to 420 megahertz. This is RF in up here, and that appears to go through something to this. Which in turn goes through this capacitor and ends up, I'm assuming, in this stage of amplification here. The final stage is here, I think. This is the output, which disappears down under the board. And then we've got this, which I think is a receive transmit relay. And I would imagine in the receive mode, which is what it's in now, these two should be connected. And they are indeed connected. I'm guessing that this is an RF sensing circuit, and this relay throws over when there's an input signal detected here, interposing this amplifier between here and here. When the RF input dies, that implies that the transceiver wants to receive, so it just connects these two together. I've removed this, what I believe to be an input filter. I don't know. And the date code on this would indicate 1990, 30 years old, 31 years old. And it's a M1107. And this fellow, also 90, the 50th week of 1990, is an M1136. The only other active components I can see is this little transistor. So hopefully we can raise its frequency by decreasing this capacitance and maybe spreading these coils a little bit. This little RF amplifier came from AliExpress. It's advertised as a 0.5 megahertz to 800 megahertz with a typical power output of 4 watts. I've read some reviews online where they try to operate this at 30 volts or something. I think I'll stick with 12 volts. Now, in addition to taking the circuit board off the heatsink and putting some paste on, some heat sink paste, I mounted a fan on it. So without the fan, I sold this for $12. Free shipping to the United States. This amplifier, I know, requires about 4 to 5 watts of input power to cause this relay to throw over into the transmit mode. Now I'd like to look at this amplifier with my spectrum analyzer and tracking generator. But that combination doesn't have enough output power to key this relay. What I'd like to do is see if I can get 2.5 or 3 watts out of this. What I have here is a 20 dB attenuator, a 30 dB attenuator, and a 10 dB attenuator. Looks like this. tracking generator output will go into the amplifier through the 20, the 30, the 10, and then into the spectrum analyzer. I'm very much worried about exceeding the input to my spectrum analyzer. What I've done here is connected the spectrum analyzer output, that is the tracking generator, directly to the input. The tracking generator is not yet turned on. Turn the tracking generator on. I'm going to narrow the span to 100 megahertz. And I'm going to enter a frequency of 430 megahertz. Turn the marker on. You see the marker sitting at 430, and it's outputting minus 10 dB. I'll take this coupling apart. I hook the output from the tracking generator to the input of the RF amplifier. I hook the output from this attenuator to the spectrum analyzer. Now power this amplifier up. And we'll see the output here is minus 33 dBm. So we know we have minus 10 coming into the amplifier. We know here we have minus 33. So that means here and here we have minus 23, and here we have plus 7, it's the difference between 30 decibels. And here we have 27. So putting some power onto this thing, this is 10 milliwatt. And this is pretty close to 1.5 watt. The best I was able to get out of this amplifier at 12 volts input was 2 watts. I figured out a way to adjust the tracking generator output. By increasing the tracking generator output at 12 volts input, I was able to get at max 2 watts out of here. I hooked up this amplifier. I've got 70 decibels of attenuation. Powered it on at 12 volts. Blew the fuse. And so I cannot buy either one of these transistors. Now, granted, it may not be a transistor. It may be, for example, the electrolytic capacitor. So anyway, this thing is a bust, at least temporarily. What can I say? Well, thanks for watching.